Well, good morning. I'm here at my Brown Sharpe number 2B plain milling machine with an optional sliding vertical head with quill feet, and makes this just an outstanding little tool making machine. The machine is also referred to as a heavy mill because it weighs 5,000 pounds, and that's pretty heavy for a number 2 mill. And they had number 2 mills they called light mills, and they were about 1,500 pounds lighter. But I'll show you what I'm up to. I'm progressing on fixing these old junkyard machines I picked up, and this one is getting close to completion. I'll get the camera down here and we'll have a look at it. I hope you're all doing good. It is cold outside, freezing fog. I don't like that, but it's nice inside. Just don't like driving in that stuff. Okay, well, here's what I'm doing. Now, this machine, the sliding head, is driven by the 50 taper and this spline going into this hole here. And you can also, and the part's missing, is an adapter. So I'm cobbling together this adapter here that goes in here so I can replace the drive arbor for the vertical head, this, with a, I believe this is a Type A standard horizontal arbor. And of course it has to have the outside support. So the way they did this, this head's difficult to remove off the arms than the regular style vertical attachment, is they had an adapter that went in here that that would support this. Now, I found that on the Brown Sharpe anyway, that the overarm supports like this, the standard ones, are serial number to the machine. So it's hard to make things perfect independently. So they obviously machined the supports, the bearing support, on the machine itself, you know, to get it accurate. And this was a find here. This is a new old stock genuine Brown Sharpe Arbor, and it's completely intact. It has not even been used once, and it's even got the thin shim pack and the small spacers. What a find. Okay, now I got a dial indicator on that, and it's not supported. So let's see how much run out this thing has. Clear at the end. Okay, I get just about 1/1000th maximum run out on this arbor. Now that's precision. Now I got, there's, well, I'm going to do a final check of how offset this is from that. Now, if you pull on this thing, and I know it's 10,000ths or more, if you pull on this thing really hard, you see I deflected it 10,000ths there. You don't want this arbor running under a bind. So if I just put the bronze bushing in this, it would cause this arbor to pull over at least 10,000ths and run, and that would cook the journal here. You know, it's just bad to have that kind of pressure. So I have to get the, at this distance, pulling this all back, I have to get the This support hole with its bronze bushing that's yet in it, centered. You know, so it's within a thousandths or so. See, you know, I don't want it to deflect more than that, but that's too much. That's just going to cause stuff to not be good. And I'm looking at my projects that are done, and some of the simplest things can take the longest time. And it's complete. I got it hidden back here on the floor. The steady rest for my axles and is completely done. And I just got hours and hours in that thing. That's my $39 plus over $100 shipping HGR on special steady rest. But I tell you what, if you got an Axelson lathe and you're missing a steady rest, you got a problem. I don't want to go through that again, but I'll probably have to. Okay, yeah, I got my other Axelson junk stuck back there. See the chocks? Those are all cleaned up. Getting a little dusty. I better put some oil on them. Okay, so I'm going to get this mill finally fixed, and I've got another problem with it, and the gasket has failed down here on the knee. And I've worked on the knee on horizontal milling machines, and it's really a horrible experience. I know, you know, there's a lot of parts. But this, the Brown Sharpe, I've never done it. You pull a couple of these things out, and the whole guts is stuck on this. The whole drive thing drops out, and I have to drop that whole thing out to replace the gasket. And then I got something going on with the power feet. I think it shared a pin or something, because it works, and if you put pressure on it, it kind of slips in a weird way. So I'll figure that out. At least I don't think there's a busted gear in there. Okay, but what I got to do with the horizontal arbor is cut some gears for the axe and lathe to cut metric threads, and what other change gears I need. Now, over here at the tool and cutter grinder, if you have one of these machines, you can get in trouble in certain ways. And remember I showed those little automotive boring bar cutters? Now look at this. There's there's more than 100 of them here. Look at that. For me to do, and then when they're done, I put them in these cool little boxes. I can do that. But one of the things that's interesting about the tool and cutter grinder is you can do all kinds of things with it, and I think a lot of people would look at sharpening 100 of those little cutters and just go, oh my God. Well, I kind of am a little bit, but it's not going to be very hard because I've got a little bit efficient using the machine. And I noticed I don't have time to look at other machining videos and stuff because I do this all the time in here. And when I get on YouTube, I look at old boxing and old movies and weird stuff like that. I don't look at machine stuff much. But sometimes, you know, headlines or whatever popped up, and I'll look at them. And one fellow was using the cutter grinder and a wheel failed. And that's really common. And I think that might be one of the reasons you don't see many videos of the tool and cutter grinder on YouTube because it really is kind of a dangerous machine, and you're going to have accidents with it. If you use the machine, you're going to crash into a wheel and it's going to explode and scare the crap out of you, you know. But you just got to stay out of the burst line. And let's have a quick look at the grinder here. I got a setup on it that is probably particularly dangerous. Now, I get a light going here. Now, I got a cup wheel in here, a vitrified aluminum oxide cup wheel. Now, these are the most susceptible to blow. And I've probably blown 3 of these on this machine in the past 30 years. And it just happens. It scares the crap out of you. And I've got this guard on here that somebody fabricated. And it's been all its... I think it failed. I busted a couple wheels with the guard on it, and it seems to catch the pieces and drop them out the bottom, kind of thing. So if you can, you should have a guard of some kind, because somehow it does seem to really help. But you just want to stay out of this direction here. And two of the times I've blown these wheels, I also blew one of these wheels using the tool post grinder on a lathe, grinding chuck jaws. And you really got to be careful doing that and stay out of the burst zone. And you really can't have guards on much of the time with the grinders. So when you're grinding high-speed steel is a lot more dangerous than grinding carbide, because grinding carbide with these diamond wheels here that's got the diamond glued on there, the worst thing I've ever seen happen is little chunks of this stuff fly off, but that's nothing like one of these blowing up. And a cup wheel, when it blows up, it sounds like a revolver going off. And it's really disconcerting. But it's bound to happen using the cutter grinder. So really be careful. And if you have to be in line with the wheels sometimes, I found I could put up something like an angle plate or something, clamp down an angle plate on the table or the machine that would, catch the burst line. So if you're getting into the tool and gutter grinder, expect to break a few eggs, and but the machine just adds so much. That's why I put up with it, and I think that's why not a lot of people are going to show very much with the cutter grinder. And you're doing things with wheels that you don't normally do, like with a pedestal grinder, you end up side loading